Hello, grade nines. Okay, so we're doing fractions in the denominator. Now, you know that the first question is going to be, you know, our golden rule for equations, right? What you do on one side,
you do on the other, right? Okay.
I think we've got that. So let's go and make it maths. Okay, so let's run through a few examples and see how we do on them. So we've got here, sneaky calculator. I don't think we're going to need the calculator just yet, but maybe we'll need it just now. So let's get rid of that. So solve for x. 15 over x equals 3. Now what we want to kind of do is link this to how we solved our equations before. So before we had this idea of finding some sort of lowest common denominator, and we're going to stick with that idea. Now, you might think, okay, so for this question, before we even think of lowest common denominator, just looking at that equation there, 15 divided by something equals 3. What is x? What is that something? And how did you find it without any kind of strange methods we're going to go into? Well, I don't know, maybe you've written something like, well, 15 divided by what gives you 3? Well, that what must be 5, right? Like, put it in. 15 over 5 is 3. 15 divided by 5. Maybe you started wanting to multiply things on each side, and that's kind of where we're going to go to. So, as I said, we're going to develop a strategy that's going to help us with more complicated equations coming up. But for this one, of course, if I asked you what 15 divided by x is 3 and you went x is 5, I'd be like, yeah, rock on. That makes sense, right? Did he just say rock on? Yeah, maybe. Okay, so we're livening things up again. So for this one, 15 over x equals 3. Let's look at it in terms of lowest common denominators. What could we write this 3 over what? What could we write this denominator? This one over, there somewhere. What could that be if we wanted to write 3 as a fraction? Well, I don't know. I could just write the number 1 and back into your box in that corner. Okay, so 3 over 1. So now the next question is, what is our lowest common denominator? Well, maybe you've got it, maybe not, but here our lowest common denominator is x. In other words, we could write each side of our equation with x in the denominator, and we could kind of do that just by multiplying by something. So let's go. This is still 15 over x. Now we ask ourselves the question, well, what do we need to multiply 1 by to get to x? Well, we need to multiply 1 by x, and this always feels like one of those things like, what you do to the bottom,
you do to the top.
It's too good, come on. So times x, so therefore that's the same as 3x over x. Now, I know we're flying along here, so let's just in a working space check. Well, if I asked you to simplify 3x over x, how would you simplify 3x over x up there? Well, I don't know. I guess you might just go, well, cancel those x's. It's one term over one term. Cancel those. So 3x over x is just 3. Well, that is what we had before. So that's probably a good sign. As I said before, it feels like overkill for this first example, but it's a strategy that's going to help us. So we are over there. Let's scroll down so we can just see the bit that we're on. Okay, well, if the denominators are the same, if the denominators are the same, it's like I want to press the button again. Well,
the numerators are the same.
Okay. Well, okay. I'll hold off now. So therefore, 15 equals 3x, and then we can solve our equation. 3 times what gives you 15, or perhaps you said divide by 3. Therefore, x equals 5, which is what we said right at the beginning. And you can leave it. Remember, I said this before. You can leave it as 5 equals x. You don't have to rewrite x equals 5. We've solved for what x is. So there's our first example. Let's run into a few more. So 4 over 3x equals 2. Let's just do this in the strategy we've just done. And then, let's just stick for that for now. So this is going to be here. So the question is, what's our lowest common denominator? Well, if we write this as 2 over 1, then our lowest common denominator is 3. Reason being, we can multiply that by 3x to get 3x. Therefore, what you do to the bottom, you do to the top. So 2 times 3x is 6x. In other words, 6x over 3x is the same as 2. Kind of makes sense, I think. 6x over 3x goes twice. 3x goes in there twice. Okay, denominators are the same. So therefore 4 equals 6x. So therefore what's your value of x? Well, divide both sides by 6. So we get 4 over 6. Now remember that you always need to, sometimes. No, always. No, wait. Well, I'm going to say 99% of the time, it's only a probability, I think, that simplifying your fraction isn't necessarily the best idea. But in this case, we need to simplify our fraction, so x equals 2 over 3. So yes, you do need to go from this step to this step over here. Just simplest form is what we go for with fractions. So x equals 2 over 3. Okay, so let's see our strategy for this one here. Let's stick with that. So in this case, we've got two fractions, and when we want to add or subtract fractions, sorry, I just got a call. We add or subtract fractions. Yeah, no, I'm just busy with the grade 9s here. I'm asking if they add or subtract fractions. What do they need? No, I think they'll be able to. Yeah, no, I think they'll be able to answer it. I need to go. So, when you add or subtract fractions, what do you need to do? Well, you look for a lowest common denominator. And that's kind of, you see, that same piece of the puzzle. We're looking for a lowest common denominator. So over here, let's look for a lowest common denominator for the entire equation. So we're going to write this as 3 over 1. What do you think your LCD is for all of the terms in this equation? What is your LCD? Well, I want to go for 2x, because if we write 2x over here, we can just multiply each denominator by something to get 2x. So 2, what do we need to multiply 2 by to get 2x? Well, we just need to multiply it by x, and what you do to the bottom, you do to the top, so therefore that's x. Now let's look at it for the next one. So let's go for nice light blue. What do we need to multiply x by to get to 2x? Well, we need to multiply it by 2. So therefore, we must multiply this by 2. So plus 3 times 2 is 6. There we've added that, and now we've got one term on the left-hand side. Okay, and so for our last bit here, we've got a 1 over here. What do we need to multiply 1 by to get to 2x? Well, we need to multiply it by 2x, so therefore multiply that by 2x gives us 6x. Okay, so go for it. Describe just fairly briefly how you're going to solve the rest of your equation. Well, I don't know, it could vary slightly. My strategy from here would be, well, I'm going to say that the denominators are the same, so therefore my numerators are the same. So x plus 6 must be 6x. And then let's solve our equation. So from here, I want to subtract x from each side of my equation. So I'm just left with 6. And on the right-hand side, if I go 6x minus x, well, then I get 5x. And, well, now I want to divide both sides here by blue it is. Divide both sides by 5. So 6 over 5 equals x. Okay, and then we're done. And if we really wanted to, we could go back and substitute it into the original equation, but I don't have time for that. So let's do our next example here. Now we've got a whole lot of fractions going on, but our strategy now is helping us quite a lot, because our strategy is, what we want to do is we want to write a lowest common denominator for the entire equation here. So in this case, what is our lowest common denominator? Well, we need something that 5x, so 5x needs to go into it, 5 needs to go into it, 3x needs to go into it, and finally 3 needs to go into it. And that thing that they all go into, I think is going to be, well, it must have a 5 and a 3, so 5 and 3 is 15, and it must have an x. So I'm going to go for 15x as my LCD, and I'm actually going to write it over here, 15x. It's captured over here by our fractions. So 15x. So now we just go through and ask our questions. What do we need to multiply 5x by to get to 15x? Well, we need to multiply it by 3, don't we? Times 3, so therefore multiply the top by 3, so that's going to be 3. Then for our next term, we've got 5. What do we need to multiply 5 by to get to 15x? Well, we need to multiply that by 3x. 5 times 3x is 15x. What you do to the bottom, do to the top. Don't forget this minus over here, minus 3x. Equals, and onwards, upwards. What do we multiply 3x by to get to 15x? Well, we need to multiply that by 5, do to the bottom, do to the top, 10. Think we're looking good. Hopefully, I'm just getting so excited. I don't know if my multiplications were right here. 5 times 3, God, that seems to work, right? What do we need to multiply 3 by to get to 15x? Well, we need to multiply that by 5x, so therefore we do that to that. And we have, don't forget this minus over here, minus 10x. So just keep an eye on that minus. I feel like that's one little bit we might not, or we might just slip up on. So we've got 15x, so therefore numerators must be the same. So let's go for, I'm just going to go blue because I'm going to give up on my colors and just say, and give up on writing. Well, you know, I'm practicing all weekend. You don't have to remind me. 10 minus 10x. So the question is, what do you get as your value of x? Well, in this case, I'm going to add 10x to both sides. So I've got 7x, because if I added 10x to both sides, then that plus that. And what I'm going to do to each side of my equation also is, I don't want this 3 over here, so I'm going to subtract 3 from both sides, which will give me 10 minus 3, 7. And 7 times what gives you 7? Well, x must be 1, right? I don't have to go to over 7 over 7. So that's that. I get so excited. I'm like, yeah, go into the next example. But that's that. Okay, well, that was a little bit of fun. Hopefully you enjoyed it. And, oh, well, I guess I'll see you in the next one. Of course, I know what you're going to do is make it maths. So enjoy exercise 19 on page 51.